Okay, my friends, I've been warning about this for at least 10 years now. Submerging skylines, major East Coast cities, including New York City, D.C., rapidly sinking. And this just came out today, January 5th, 2024. Not only are they rapidly sinking, all the sinkholes that are showing up primarily because we've taken all of the inflation out of the earth by pumping out all these gases and oils. At one time, you poked a hole into a gusher, you'd get a gusher. It would squirt out of there like way up in the sky, these oil, because they're under so much pressure. The earth had a pressurized surface. It's no longer, everything's falling in. This is just started. Just started, my friends. All right, I'm just going to leave it at this. Submerging skylines. It's just out today, and I've been talking about this for years. This is right on the edge of the water. All it's got to do is sink a couple of feet, and it's all over. And it is, and it will. And they're talking about high-risk areas, and these are where these dense populations are the high-risk areas. They show them all up the East Coast. Now, down here, we get to the point where it's going to make, I'm going to leave it at, if I can find it. Here it is right here. Now, they're talking about the subsidence and infrastructure, which means the infrastructure is all the buildings. It's going to, if the structure or foundation gives way, it's all over. And these buildings are very, very heavy. Now, this says, the new findings appear in an open access journal, PNAS Nexus. In the work, quotation marks, slowly but surely exposure of communities and infrastructure to subsidence on the U.S. East Coast. It's everywhere in the world, so they're just talking about what they're documenting in this. They can actually see it sinking. Virginia Tech and U.S. Geological Survey scientists measured how much the land along the East Coast has sunk and which areas, populations, and critical infrastructure within 100 kilometers of the coast are at risk of land subsidence. It's not only close to the coast, but they're focusing on that because that's where they can see the water level is going to take over. Now, the subsidence can undermine building foundations, absolutely, damage roads, gas, and water lines, cause building collapse, and exacerbate coastal flooding, especially when paired with sea level rise caused by climate change. So the two of them are going down. The buildings are going down, the water's going up. Sooner or later, it's all over. It says this information is needed. No one else is providing it, said Patrick Barnard, a research geologist with USGS and co-author of the study. Shirazi and his Virginia Tech team stepped into that niche with his technical expertise and is providing something extremely valuable. This knowledge is just overlooked, and the pressurization that we are removing is the cause of a lot of this, or a ton of it, almost all of it, basically. If the land was pumped up like a nice tight balloon, we'd be all right. But we popped holes in it everywhere, and we're sucking it out. We're sucking the gas out of it. It's going to just deflate, and it literally is deflating. That's just a fact. Okay, well, there's really not much we can do, but I suppose it is better to know than not to know. We have high-risk urban areas, and a lot of it is due to the weight of all the buildings that are there. Huge buildings, and they're right on the edge of the ocean. So you have a lot of moisture going on, and you got all these big heavy weight, and the Earth itself is literally collapsing, and the Earth's surface is collapsing due to the removal of these pressurizing gases. And when I say pressurizing gases, I'm talking about fossil fuels, gas and oil, methane gases. They pumped up the earth like that. They hold things up. Well, that's not happening anymore. There's a general subsidence of everything going down. But worse than that is all of these little pockets that are here and there that were normally filled with fluids, and they're being drained. And as that happens, you get these sinkholes all over the Earth. And we're losing pressurization of the Earth. That's why we're getting this rapid subsidence. Listen to what it has to say about the particularly hard-hit population centers like New York City, Long Island, Baltimore, Virginia Beach, Norfolk. They're seeing rapid subsidence. All right, and it will, I'm quite certain, get worse. And I don't think there is anything we can do about it right now. But like I said, I think it's better to know than not to know. So subsidence is sinking land, alongside more slowly sinking or relatively stable ground, increasing the risk to roadways, runways, buildings. So think of it, what they're telling you right now is you have sinking land, which was where all the heavy buildings are and so forth, and they're subsiding. But they are alongside some other slowly sinking, relatively stable ground. So you got it here, and you got it over here, and this one's sinking, and that one's not sinking as fast. And this is not due to necessarily what they're thinking. There's different textures to the ground. So, and I know why that is, but we'll talk about that later. But this is, they know this is a fact. This is sinking, this is not sinking as fast. So you get unstable ground. Increases the risk of roadways fracturing, that type of thing, rippling. Runways in airports, because this is all right where the airports are and all that. Building foundations, the foundations can crack and change. Rail lines, pipelines, anything that is feeding through the earth or even on the earth is subject to this change. All right, so this is a study published in January 2nd, Proceeding of National Academics of Science. Now, what do the experts say? Expert insights on infrastructure impact. All right, this in quotation marks. It says continuous, unmitigated subsidence on the U.S. East Coast should cause concern. Absolutely. And that's from the lead author, Leonard Owenham, a graduate student working with Associate Professor Manicham Schliers at Virginia Tech's Earth Observation and Innovation Lab. This is particularly in areas with a high population and property density. The weight, basically the weight and the people and all of the infrastructure and all of the fluids that are necessary and all of the buildings and all that stuff. It's got a weight to it. And it's a historical complacency toward infrastructure maintenance. Nobody's paying attention. And like I say, I did a video on this 8 years ago. And I think I mentioned that. And as a matter of fact, I think it's right here. Nope. Well, I'd have to look it up. But this is not going to end up well. All right, and I think they understand this. Submerging skylines, major East Coast cities, including New York City, D.C., rapidly sinking. Think about this. Look at the water. The water's just ready to go in there anyway. All you got to do is go a little bit higher on this. And the oceans are rising sea levels. The land is sinking. So you got to... This is not going to end up well. I don't think they can build seawalls that will keep this kind of thing from being a problem. But how do you repressurize the earth? I don't think you can. And God, look at all that weight. Can you imagine how much weight that is on the earth? I don't think it was thought about well. But we'll have to see how this turns out, my friends. All right, I love you all. Stay safe. All right, my friends, it's not good news, but there's only one way out of this that I can possibly think of, is to let the earth repressurize itself. And it will, because of the decay of things inside of it turning into gases. And that's what creates the natural gas and so forth. But that will repressurize the earth. But you have to stop pumping all this stuff out. You can't do it. You can't take all that pressure out and hope for the best. It's not going to happen. So what could possibly work? Well, this is light being accelerated, and this is light being divided. All you want for energy is that white part. we force the black part of the white to stay, of the light to stay away. The white part is a part you put in your batteries when you charge your car. It weighs 4,000 pounds. And it's empty. There's no charge to it whatsoever. It can't move. There's no energy. 4,000 pounds. You fill it up with energy, and it still weighs 4,000 pounds. Didn't change. That's because all you put in was this white, and this white has no mass to it whatsoever. It's strictly burn, and I cannot explain that, but they know about that at Fermilab and CERN and everywhere else. They can't explain it either. I can show it, and I can tell you right now, that white is all you want to put in your car. And we can separate it by using this Venturi. And it shows a new particle structure, the whole thing. Protons are not made out of quarks and all of these little particle zoo that they have. They're made out of little dipoles. We broke the dipole here and reassemble it over here. And in the middle, all you have to do is take that white and dump it down. And I'm going to show you the device that I'm talking about could work right here. You see this? You're shooting your laser through. It's coming the black and white particles together. The white, though, can squish down. So you make a restriction so tight that the black can't get through. It just can't get through. The white goes glip and goes squirting right through. And then the white gets collected and you can do whatever you want with it. So that we didn't have to do anything. Now Lawrence Livermore is doing the same thing, but they're not doing it the way we're doing it. We're doing it much simpler. They're using all kinds of things. But this is what they're doing. Electron showers, which is what we created. And these are the muons. They back off. The electron showers get stronger and stronger as they come through, which is precisely what I showed you right here. These are the black particles along with the white particles. They stay away. The white ones go through, and then they recombine over here to come back to their natural photon configuration, black and white attached together. In the meantime, this is nothing more than free electricity. If we could do this, that's the only solution I can see. Not only that, it should be free energy and portable. Carry it around in a little lunchbox like that. Put a bunch of different outlets on the different outlets. You can plug into anything you want. AC, DC, 50 cycles, 60 cycles. You have all kind of little regulators in there, and you could have as many of these as you want in there. You could probably have 1,000 different receivers inside this one little box, and I don't see why that shouldn't be able to power a car or anything. Inside of something that big, you carry around like this, and it cannot hurt you because you're working with light. You're only using light. You're not using the big particles. In other words, what they're using right now, when they use nuclear power, they're starting with huge things like this. When they break them, they're throwing off chunks like that. That will hurt you. That will kill you. That will destroy your cells. We're working with light, so we started there. So we didn't start with all that chunks. So when we split it up, all we did was split the white from the black. And that's all you want anyway, was the white from the black. But in order to do it, they just use splattering things all over the place, and then they get a little bit of white here and there, and then they're happy. Well, I'm not happy with that. This is a much better design, and it's been overlooked because it interferes with the oil situation, all kinds of things. I'm sorry, this is just the way it is. If you want to keep the earth going, you're going to have to do something. And I would start with looking at something like this, because if this worked, you could carry that around. You don't need a grid. There's no damage, there's no energy, there's no expansion, there's nothing. It's just absolutely just energy. And once you turn it on, you should never have to turn it off. Until something breaks down, and then in the meantime you could have 5 or 6 or 10 or 100 of these different ones in there, and it'll just roll over to the next one if it goes bad. This is literally, and I'm not kidding you, I mean it exactly as the words are going to come out of my mouth, this is a subatomic nuclear explosion. All right, you listen to me, a nuclear explosion, subatomic. We broke the white from the black and created this enormous amount of illumination, which is nothing more than energy. When you see illumination on steroids like this, that is just energy. coming from almost no energy at all. So I don't see why we shouldn't take advantage of that. Put a collector right there and shoot that down, because it's being slapped by that black particle. Let me show you a closer up, and then I'm going to close it up. But we got to do something. We've got to do it very, very quick. I mean quick. And I still got to be honest with you, I don't see it being able to be reversed. But like I said, if you don't know, you don't know. If you know, who knows? All right, I showed you the light acceleration, which was this right here. These are the particles at CERN, Fermilab, Lawrence Livermore. They see them. They know they're there. But they're using huge particles to start with, so they just see them in a big mess of debris. We started with light, and this is what light is right here. That's a photon. A black and white attached to a black and white. They're just exactly identical to two-bar magnets. As they move through the air this way, this one right here, I don't know if you can see it or not, but there's all this little glowy stuff in front of it. It's got to compress this against it. They both glow. That's why you see a little taste of glow there. I think you can see that. Hold on. You see the little glow in front of that one there? Up above, that one there has no glow because it's blocked by the black particle. And see how dim it is compared to the other one down at the bottom? Now, what that means is this one will charge up. This is the electron neutrino. This is the muon neutrino. The two of them together make what they always thought was an electron. Nobody ever knew about the dark matter. That's the dark matter. That's what they've been looking for. That's what makes up mass. Light is just the tiniest part of mass there is. All right, I showed you that light is like this. Right down here. It's actually two of these particles. That's a little magnet, and there'd be another magnet attached to the side of it. And it goes through the air, and they spin like this because this one charges up, and it gets dropped to the back. That one comes to the front. It charges up, dropped to the back, and they just spin as they go through the air. And that's because they have to compress everybody else out of the way. Get out of the way, get out of the way. And this charges up. Now, the beauty of this, though, is it can shrink down to nothing. So if we made a restriction small enough, and we did, right here, you see the light here? It's being accelerated because it's a Venturi. And if you don't understand a Venturi, look it up. It accelerates, it compresses. And at the Venturi, the black could not get through with its white counterpart. This is nothing more than this right here. This is just colorized and shows the energy levels. And this is just a black and white. Now, what are we seeing happening at the Venturi? We can see we just got a pile of white. Well, what does that mean? Well, let's look at it over here a little closer. This is nothing more than this right here, real close up. And you saw the black and white were attached together. No longer attached together. All right, they're no longer attached together. Normally, they were this muon neutrino, the black ball, and the white ball was the electron neutrino. All right? Electron neutrino, muon neutrino. Those two always want to be stuck together. That's really what an electron is. They are almost impossible to rip apart. To generate electricity, you have to do a lot of work to just rip that white one away and push it down into a battery. That's what happens when you generate electricity. You take basically this. You take molecules, and there's electrons all over that, and you have to grab them and rip them off, and just rip off the white part and send it off into a battery to be held. And when you do that, the battery doesn't gain any weight at all. These have no weight whatsoever. And that's exactly what Fermilab says. And this is actually from Fermilab right here. And as a matter of fact, let me tell you, I'm going to read to you exactly what they say about that particle. It has no weight whatsoever, but it has a huge magnetic field. This has all the weight and has no magnetic field. Well, it attracts the white. All right, the white is so attracted to the black that it will run through wires and push motors and heat up elements and any kind of resistance it flows through just to get back to the black. They want to be attached so tightly that that's what electricity is. That's what lightning is. The white wants to get to the black. And the Earth obviously has to have more black because the white wants to get to the black. So when you get static on you, it goes right to ground. Electricity in the air, excess of these go right to ground. That's what lightning is. That's what static is. Electricity. It's excess electrons trying to get to a ground. Now, let's look into this for a second. You know, let's just leave it at this. I think I've made my case, and the only possible thing we have is to create free energy. And something like I just showed you, if it works, and I don't know if it'll work for certain, but it sure looks good. As a matter of fact, hold on. All right, I showed you our light experiment particles. They're identical to these particles, 100% identical, even with the glowy edge around the black. And this is what they say about these two particles, which is exactly what we discovered. In summary, the extended particle, which is the black one, has a fixed size, never changes. That's why when we make that slot so tiny, it can't get through. It has a fuzzy edge around it, which is the color. Again, there it is right there. That's the color right around it. Exactly what they show. That's from the Fermilab article. I'm just showing you. So they know that it's the same particle. And it's fixed. It never changes, the black one. It's got a fuzzy edge around it, which is the color basically. The point-like particles are mathematical extractions with zero size. Now, I don't know. It appears to be correct because they have no weight. I know that. It says even zero-size particles have an extended field, extended effect, which is this big magnetic field. I'm correct about that, 100%. And it's due to the effect of the field surrounding them. Well, what is it surrounding? That I can't understand, because they have no weight. You charge your car up, and it never changes its weight. You run all that out. Never changes weight. You take a car and put gas in it, you just put in 60 pounds of gas. 60. And then that turns into all kinds of problems and gaseous emissions. We have to get away from all that. You charge up your battery, you may not even have to charge it up with one of the devices I'm talking about, because these devices would be so small and be so powerful. If it works, again, you got to test it. But nobody's been able to do this before, to separate and get the muon neutrino and the electron neutrino separated, which is, by the way, fission and fusion. That is fission. The black has been broken away from the white. That is fusion when it comes back together. This is what everybody wants, is the white. We got it right here. And this goes back quite a ways. I've been trying to push this. By the way, I'm doing a special on opals today too. All right, I love you all. We got to do something. This is not good at all, my friends. All right, submerging skylines, not good. All right, I love you all. Bye.